Good afternoon, everyone. I'm going to talk about the grid battery of the future. So the lithium-ion battery, as you know, is a fantastic battery, but it has some challenges. And the first challenge is obviously fire and explosion. This is called thermal runaway. And in a lithium-ion battery, it's virtually impossible to put out the fire, because if you douse the fire, a normal fire would just go out because you take oxygen away. What a lot of people don't realize is that you actually generate oxygen at the cathode end of the battery, so virtually it's impossible to put out. The other thing is that lithium-ion batteries have very limited temperature ranges. So they only operate between 15 to 35 degrees. So in the very cold, the battery actually slows down. That's one of the other challenges. And the third challenge is that the life of the battery is generally about 8 to 10 years. And then the final challenge is the critical metals concerns. So you've seen the price of lithium go up 5-fold in the last 18 months. This is a concern for the industry. The other concern is the cobalt supply. Ethical concerns, because 70% of cobalt comes from the DRC, and we know about child labour and labour issues in the DRC. So this is a concern for the battery industry. The other concern is that 90% of graphite comes from one country, China. So can you imagine all the supply of lithium batteries coming from one country, which is a geopolitical risk? Finally, the copper crunch. There's research that shows there's not enough copper mines being developed to service just the EV forecasts. And then also, finally, manganese. So my question to you, is there a battery that can actually is fireproof, can operate in a large temperature range, has more than 15 years life, no lithium, no cobalt, no copper, no graphite, no manganese? So this is our Cerenergy battery. Essentially, it's a salt and nickel powder battery developed by the Fraunhofer Institute of Germany, the Battery Institute, and we have a joint venture where we own 75% of the project to commercialize this technology. So essentially, you can see there, the main ingredient is actually salt. So what does this battery look like? One of the benefits of the battery is that, as I said, it's totally fireproof. The life is beyond 15 years. It operates down to very cold temperatures, because in the battery it operates at 270 degrees. It's fully insulated, and it's a bit like a mammal. It can operate in very cold climates as well as hot environments. The cycle life is beyond 15 years, and the best thing about it is it uses sodium ions. Sodium ions is very reactive. It's just under lithium in the periodic table, and it's totally cobalt-free, as well as the copper and graphite-free. So how does the battery work? So let me show you. This is solid-state technology. So we have a ceramic tube, and essentially, all lithium batteries are trying to get a solid state where there's no liquid electrolyte. So all you're doing is you're adding salt to it, add some nickel metal powder, you insert a positive electrode through there, and then you put it into a cylinder which acts as the negative terminal. So essentially that's what the battery looks like, and that's the finished part of the battery. 240 watts, 240 of those forms a 60 kilowatt battery. So some of the graphics, there you go, that's the ceramic. You've got a positive electrode in the middle. We fill it up with salt crystals and nickel metal powder, and then we flood it with a alumina chloride solution, and that sits in a casing, and that essentially is the battery. So from a chemistry point of view, how does it work? Well, essentially, when you charge the battery, the sodium ions migrate through the ceramic piece, which is the electrolyte, and it forms molten sodium on the other side, and when you discharge the battery, the sodium goes back, grabs the chloride, and becomes salt again. So that's the process. Very neat technology. Essentially, we didn't develop it. It was developed by the German Institute They were looking for a partner to commercialize it, a partner that had land in Germany, and we fitted that criteria. We got a battery background and we got an alumina background. The ceramic part is the alumina battery. So the unique part of this battery is a self-forming anode. It forms the anode when you charge it and it discharges it. Very neat technology. Well, how does it compare to other batteries? It's very similar to the lithium iron phosphate battery. Very dense, produces a lot of power like the lithium iron phosphate. Very safe, very low maintenance. It hasn't got any moving parts. Unlike lithium ion batteries, you've got fans, and this is actually fits in right into the grid storage market. So the market we're targeting is the grid storage market. This is the market you want to look at. Everybody's focusing on EVs. This is like the lithium industry 12 years ago. Everybody is looking at how do you take the sun's energy and shift it to the nighttime. I'm sure a lot of people have solar panels today in their house. You're generating electricity for 0 cents into the grid and you're buying it back at night at 50 cents on a kilowatt hour. Okay, so how can we shift that to the nighttime? This is some visuals of the pilot plant that was built. So Fraunhofer spent 35 million euros in the development of 8 years, and this is a shot of some of the operating pilot plants. So these batteries have been produced. You can see the yellow version is a 5 kilowatt version undergoing tests. So it's not a research and development idea. It's already been produced. It operates well. We need to take it to commercialization. So our project is a 100 megawatt plant in Saxony, Germany. As you can see, some of the ceramics been made. We are completing a DFS to build this 100 megawatt plant in Germany, and then we look at gigawatts beyond that. Where are we in Germany? We're on the border between Poland and Germany, in the east part of Germany, in Saxony. We already have the land there, and we're developing this project there. So very exciting technology, and they quote that it'll be 40% cheaper than a lithium-ion battery. Well, it makes sense. You don't have any lithium in the battery, you don't have any cobalt, you don't have any copper, you don't have any graphite, and you don't have any manganese. It's just salt and nickel metal powder. So this is the first product we launched. It's a 60 kilowatt pack running at 100 amps and 600 volts. We got so much interest saying, can we have it in the house? Essentially, these cylinders are sitting in a rack. They pull out. There's 240 of these cylinders providing 60 kilowatt power. So the market really is in the industry. So that's our vision. This is the new technology in grid storage. Thank you.